Good morning, student. In this session, we will take the numerical on helical coil compression spring for service load range. That is, the two values of W's or loads are given, that is W1 and W2, and for that deflection is given, and you have to design the spring, means you have to determine all the parameters required for manufacturing a spring. Let us have a problem. Design a closed coil helical spring for service load ranging from 2250 Newton to 2750 Newtons, means two values of W's. The value of load changes from 2250 Newton to 2750 Newton. The axial deflection of spring of the load range is 6 millimeter, means deflection delta is 6 for the load range. It is not total deflection from free length, it is the deflection for load range W1 to W2, that is 6 millimeter. Assume a spring index of 5. The permissible shear stress intensity is 420 Newton millimeter square and modulus of rigidity G is equal to 84 into 10 raised to 3 Newton per mm square. Take design stress 25% excess of permissible stress for service conditions and intermittent operations. Generally, we take the design stress when conditions are different from normal conditions. In that case, we take the design stress. Here we have to take the design stresses. Now, these are the figures. This is the figure of spring in unloaded condition. This is the figure of spring with load value W1 is equal to 2250 Newton. This is the figure of spring with having deflection delta is equal to 6 for load range, and W2 is the load, maximum load you can say 2750 Newton, and this is the solid length. Now data given: W1 is equal to 2250 Newton, W2 is equal to 2750 Newton, C spring index is equal to 5, tau permissible is equal to 420 Newton per mm square, G modulus of rigidity is equal to 84 into 10 raised to 3 Newton per mm square. For load range, W means difference of load W2 minus W1, that is equal to 500. For the deflection delta is equal to 6 millimeter. K is equal to 4C minus 1 upon 4C minus 4 plus 0.615 upon C. We will calculate the value of Wahl's factor by substituting the value of C. The Wahl's factor K comes out to be 1.3105. Now we take the design stresses. As mentioned in the problem, we have to take 25% more for the given working conditions. Now design stresses tau D is equal to 1.25 multiplied by tau permissible. So tau design comes out to be 525 Newton per millimeter square. Now we will determine all the dimensions for the design stresses. The design stresses are the stresses by which we determine all the design parameters. Generally, we take the design stress when the conditions are different than normal conditions. Here conditions are different from normal conditions, hence we take design stress. First, we determine the diameter of wire from this formula. Tau is equal to K into 8 WC upon pi d square. From this, the substituting the value of K, W2 and C and tau d, we determine the diameter of wire, that comes out to be 9.35 millimeter. While determining the diameter of wire, students are generally confused whether the value of W2 is to be taken or W1 is to be taken here, because W is written here and two values of loads are given, W1 and W2. So which is to be taken? So generally wire is designed for maximum load, so we will take the maximum value of load to determine the diameter of wire. So confusion should be avoided here, or care should be taken while taking the value of W. Here maximum value of W should be taken to determine the diameter of wire. From this formula, D is equal to C into D, we determine the mean coil diameter, that comes out to be 46.75 millimeter. Now second, determination of number of turns. From the formula, delta is equal to AWC cube N upon G into D. Now substituting the value of G, wire diameter D, delta and W, here the care should be taken which value of W is to be taken, because W is for the load range. Here W or delta is for the load range. His value is given for 6 millimeter. Delta, this delta is for load range. So this is 6, and so the here the value of W, load range, difference of loads must be taken here. The load range W2 minus W1 is equal to 500. So here the value of load range is to be taken, because we are taking delta for load range. Here care should be taken. So the value of W is 500 here, and value of delta should be taken, that is given 6 millimeter. So putting the value of G, D, delta, W or load range and spring index C, we will determine the number of turns, that comes out to be 9.42, and say we take 10 number of turns, active number of turns comes out to be 10. Now assuming square and ground end, the total number of turns N dash is equal to active number of turns plus 2, so N dash will be equal to 12. Now in order to determine the maximum deflection, the ratios will remain constant. This graph shows that the ratios of W and delta remain constant. So W maximum upon delta maximum, this ratio will be equal to W2 minus W1 upon delta. From this graph it is clear, because the graph of this nature. From this graph we have the W maximum upon delta maximum equal to W2 minus W1 upon delta. From this we will calculate the delta maximum. So putting the values of W maximum, that is 2750, delta for the load range, that is equal to 6 upon 500 load range. So delta maximum comes out to be 33 millimeter. Now solid length, from the formula we will determine LS is equal to N dash D. Putting the value of N dash and D, LS comes out to be 112.2 millimeter. And free length, from the formula LF is equal to LS plus delta maximum plus 0.15 multiplied by delta maximum. From this formula we will calculate the free length, that comes out to be 150.15 millimeter. Now pitch, the value of pitch we will calculate from the formula P is equal to LF upon N dash minus 1. So pitch comes out to be 13.65 millimeter and DI comes out to be 37.4 millimeter, and outside diameter mean to be 56.1 millimeter. In the figure we have mentioned the answers. The free length comes out to be 150.15 millimeter, pitch comes out to be 13.65 millimeter, and solid length comes out to be 112.2 millimeter. Maximum deflection comes out to be 33 millimeter. Thank you very much. This is the end of the session.